You are watching the Target 5.4 retest video. In this video, we're going to solve quadratic inequalities. We're going to look at the graphs of these inequalities. We're also going to look at doing it algebraically, and that's going to be the way that's expected. A few word problems too. So pick up the white packet, make sure that you finish it before you are allowed to retest. And if you need any extra help on it, see your teacher before or after school or during advisement. Here we go. We're going to do number 3, number 11, number 13 on the packet. Again, if you need more help than what I'm going to do, see your teacher. You can also stop the video and replay it as much as you need to. So let's look at number 3. We're going to attack all of these by factoring. So that's going to be the main mode of solving these to start with. So two numbers that multiply to be 18 and add to be 3. So let's figure out those numbers. And then the only one that has a chance of being 3 is this 3 and 6. And it's got to be a positive 6 and a negative 3 to add up to be 3. So this becomes x minus 3 and x plus 6. And figure out the solutions. We want to figure out where it crosses the x-axis first. We set them equal to 0, and we get x equals 3 and x equals negative 6. All right, so if we take a look at the graph to this one, you see that, yes, we do have something at negative 6, we do have something at 3. The original problem says, though, where is the graph less than 0? So this thing right here, less than 0. So we want to figure out where it's less than 0. Well, it can either be less than 0 in this area, or this area, or a combination of those. And if you notice on the graph, here's where it's less than 0. So it's got to be in this area. So to figure it out algebraically, we're going to take a look at each of those regions, something less than negative 6, something between negative 6 and 3, something bigger than 3, and plug numbers in to figure out which one gives us answers that are smaller than 0. So we'll come back to that graph in a second, but let's check out something less than negative 6. Let's just do negative 7. Keep the numbers as small as possible. Between negative 6 and 3, the easiest one is going to be 0. And then bigger than 3, the easiest one is going to be 4. So I'm also going to use the factored form. It's probably the easiest one to plug into. So negative 7 minus 3 and negative 7 plus 6. We're going to put those into both places. I get negative 10 here and negative 1 here. And when I multiply those, I get 10. So that is bigger than 0. So that doesn't work. I plug 0 in, 0 minus 3, 0 plus 6, I get negative 3 and 6. When I multiply those, I get negative 18. That one's less than 0, that's good. When I plug a 4 in, 4 minus 3, and 4 plus 6, so 1 times 10, that's 10. That's bigger than 0 again. So the only place where it works is this 0 point. So that 0 point, we were testing between negative 6 and 3. So we write that one as negative 6 is less than, x is less than 3. Okay, a couple things about our answer. Notice we use less than, not less than or equal to, because the original problem wasn't equal to. Also, any number in between negative 6 and 3 works. That's why we give it a range of answers, not just 0, but all of them between negative 6 and 3. All right, and that's represented in our graph by the graph being below 0. Okay, let's move on to number 11. Number 11 is not in standard form, so we're going to write it in standard form to begin with. Add 10x to both sides, add 16 to both sides, and notice that would be greater than or equal to 0. So factoring two numbers that multiply to be 16 and add to be 10 are 8 and 2. And we want to find the solutions. So that gives me x equals negative 2 and x equals negative 8. So those are our solutions. And if we were to look at the actual graph of this one, you would see that it does go through at negative 8 and negative 2. So we want to test out these regions, this region here, and this region here. So let's pick a number that's smaller than negative 8. That would be negative 9. Let's pick a number that's between negative 8 and negative 2. We'll pick -3 and start a number that's bigger than -2. Again, the easiest one in that region is going to be 0. Use the factored form and plug those in. So -9 plus 2, -9 plus 8. It gives me -7 times -1, or 7. That's bigger than or equal to 0, so that's good. -3 in there. -3 plus 2, -3 plus 8. -1 times 5, that's -5. That's less than or equal to 0, so that's not cool. And then 0 in there, 0 plus 2, 0 plus 8. 2 times 8 is 16. That's bigger than or equal to 0. So it's these two regions that work out the best. This was less than or equal to 8. This was greater than or equal to -2. So since it's the outside regions here, we're going to write this a little bit different than the previous problem. We have one of them that's less than or equal to -8. Sorry, that's negative. And we have one of them that's greater than or equal to -2. And this is an or in between. Okay, so there's two problems, and I guess that if we look back at the graph, notice it's bigger than 0 here, it's bigger than 0 here, and that's outside that area in the middle. So that's why we wrote less than or equal to -8 and greater than or equal to -2. There you go. Last problem we're going to do is the word problem here, and we're going to take a look at this rectangle. We want an area that's larger than 24, so that's bigger than 24, and the length is 2 inches more than the width. So here's the width, the length is 2 inches more, W plus 2. So the inequality we're going to write is W plus 2 is greater than 24. Now this one's already factored, but we have that 24 on the other side, so we're going to have to unfactor it or multiply it out. Then we're going to have to subtract 24 from both sides, and then refactor it so we can find these solutions. So that gives us two solutions of -6 and 4. Now -6 as a W, as a width, will not work, so we're going to focus in on this one. So we want to find all the widths that provide this area of larger than 24. So if we focus on 4 as a solution, we want to figure out which side of 4 gives us answers. So again, looking at the graph here, we're going to have an area on this side of 4, an area on this side. We can also test this one out too, but remember this is the negative point that doesn't really have much context in this problem. So we're really focused on this solution. Now, so we need to test out some points. Move this graph out of the way here. Test a point that's smaller than -6, so -7. We'll test a point that's between -6 and 4, that's 0. And we'll test a point that's bigger than 4, we'll test 5. -7 plugged it into the factored form. Gives me -1 times -11, or 11. That is not greater than 0, or that is greater than 0, sorry. 0. That gives me -24. That's not greater than 0. It's actually less than 0. And then we'll plug 5 in, sorry. That gives me a number that's greater than 0. Okay, so remember now, this one is not one that we will be focused on. So we want numbers that are bigger than 0, and that'll give us this region that is here, or greater than 4. So we're looking for widths that are greater than 4 as our answer. All right, there you have it. There's all the problems that we're doing in order to retest, finish that packet, and as soon as you're done with that, take it in and retest.